Hello everyone, my name is Supriya Bhosle, Assistant Professor, Computer Engineering Department from AISSMS Institute of Information Technology. Today we learn about the concept related to the data structure and algorithm. Topic name is stack. Let's see the definition of stack. Stack is data structure in which addition and removal of an element is allowed at the same and is called as a top of stack. So stack is actually the linear data structure that follows LIFO. It's nothing but the last in first out principle where the last element inserted is the first to be popped out. It means both insertion and deletion operation happen at one end only. That's why the stack is called as a LIFO, last in first out. It means the element which get added at last will be removed first. Suppose you are considering here the examples like stack of plates. When we add a plate, we add at the top. When we remove from the top. Means we are adding and removing from one end only, and that end is called as a top. Same example, the stack of the box, stack of book are the example of stack. So in this diagram, it's an example of stack data structure where you can see the two diagrams here. The first diagram is having a 3 element in a stack and the second diagram is having a 2 element in a stack. In first diagram, the top indicate that the first element or the top of the element in a stack, that is nothing but the C. Suppose you want to add a new element, so we are inserted from the top only. Suppose here in this example, there are only two elements present in a stack and you want to push the character C. So we are inserting by using a operation push. Suppose you want to remove the character C from the stack. So we are just use a pop operation to pop the element from the top. So insertion and the removing, both operation are done by using a top of the stack. Now, after removing the C in a second diagram, the top will be now pointing to the last element in the stack, that is nothing but the B. These are the component of stack. Top is nothing but the variable which refer to the last position in the stack. Element is a component which has a data. And max stack is nothing but is a variable that describes the maximum number of elements in a stack. Suppose you want to store the elements in a stack with some specific size. Suppose you want to store the marks of a student, 100 students. So the maximum size of stack is nothing but the 100. So the max stack is nothing but the variable. It just define the size of your stack. These are the main two operation, push and pop. Push is nothing but it add a data to element in the stack, and pop is nothing but it just take a data from element in the stack. So stack we are considered as an abstract data type. Stack is an abstract data type which is defined by the following structure and operation. So all these are the basic operations we are performing on a stack. The first one is a create, second push, third pop, 4 pick, 5 is empty, 6 is full, and 7 size. So we'll see one by one. So the first one is a create stack. Create stack is a function we are going to use to create a new empty stack. Push operation is basically used to storing an element on the stack by using the top. Pop operation is just remove an element from the stack. So we are going to use a pop function. The next one is a pick. It's basically used to get the top data element of the stack but without removing it. In pop we just remove the element, but in pick we are just get that top element but we without removing that element. So this is the difference between pop and pick. Each full is a one type of condition we are going to check in your program to check if the stack is full or not. If you are defining the stack size 10 and you want to add some extra element, means 11th element in the stack, it's not allowed because the size of defined stack is 10. So always when we are going to insert or add the element into the stack, at that time we are going to check a is full condition. Is empty means suppose you want to remove the element from the stack. Before removing, you have to check for the empty condition of stack. So check if the stack is empty by using is empty. If the stack it does not contain any kind of element, so it can't do the pop operation. So before removing the element from the stack, you have to check a condition is empty. The next one is a size. Size is written the number of atom in the stack. So when you want to check how many number of element present in a stack, it is calculated by using a size operation. Here, the stack representation using array and linked organization. The first diagram, it shows the stack representation using array. So there are the three elements are present in a stack, 8, 45 and the 10. So the top is represented and pointing to the last element in the stack, that is nothing but the 10. So this is a simple representation of stack by using array. By using list, the linked list is nothing but it is a collection of the nodes. The nodes are connected with each other. So if you want to add a three element, so we are created here three nodes with the value 10, 45 and 8. Every node is having a two field, data field and the address field. So address field is actually used for the connection between the two nodes. So it stores the address of next node in the address field. Suppose you are considering here the head is a pointer going to use in a linked list to store the address of your first node, that is nothing but the top node. So the top node is nothing but the 10 and the address of that node is a 6040. So that value is stored in a head. So this is actually the top node that is connected to the next node. So the address of next node is stored in this node, that is nothing but the 4500. Afterwards, 45 is connected to 8. So the address of 7000 is considered here to attach with this two node 45 and 8. So the last node address become a null because it is the end of your linked list. It is always denoted with a null pointer. Thank you.